Okay, I'm going to go ahead and start recording us though. Can you guys see my screen okay?
Yes.
Wonderful. Okay. So if you guys had been here in person, this is what you would have seen when you walked in. So when I see you guys in person, hopefully tomorrow, fingers crossed, you will pick up a prime math book. They are pretty thin this semester. If you had this class last semester, very similar size. They're about this big, blue cover, maybe about 1/4 of an inch, 1/2 an inch thick, not very big. We're going to be covering 4 units this semester. We did 4 units last semester. We started with unit 8, and then we did 1, 2, and 3. So this semester, we're going to start with unit 4. We'll do 4, 5, 6, and 7. Unit 4, we're going to start off with linear functions. When I see you guys in person, you can choose to sit wherever you'd like. I do ask, excuse me, that you stay there until we are done with the first test. I have to have a seating chart in place just in case we have to do contact tracing. If you pick a seat and after a couple of days, you're like, this spot just is not working for me, just let me know. That's fine. I'll just need to make sure that I update the seating chart. And then at the end of each unit, if you want to get up and move to a different spot, that's totally fine. As long as we don't have any problems, you guys can continue to choose your seats. If we have any disciplinary problems, cheating problems, or if there's any issues with, some people are having difficulty seeing or hearing or whatnot, we might have to do some reshuffling and I might need to move you guys around. Last semester, there were absolutely no problems with this, and I usually don't have any problems, so I don't anticipate any issues. One thing I do want to make sure to let you know is if I do ask you to change seats, I am not accusing you of anything. Like I said, there can be a lot of different reasons why I might ask people to move, including vision or hearing issues. And so if I ask you to switch spots with somebody else or to move to a different spot in the room, I am not saying that you're cheating. I'm not saying that you're a discipline problem, nothing like that. And if I ask you to move somewhere and that's not going to work out for you, just let me know why. And I will make every accommodation that I possibly can so that you're in a good learning environment. My bathroom policy, go when you need to. There is a laminated bathroom pass. There is 1 laminated bathroom pass. So if someone has already gone to the restroom, you need to wait for them to come back, and then you can take the pass and go to the bathroom. Just be aware that anything that you miss while you're gone, you are responsible for catching up on. I do post notes and a video every single day, not just days that we're on Zoom. Let me show you real quick where you can find those things. So from our class Canvas page, looks like this right here. You're going to scroll down just underneath the Zoom link. It says click here for today's lesson. That will take you to our daily page, which is what I was on when you guys first joined for today. And that'll kind of go over what we're going to be doing that day. And if you scroll down right here, I'll have the notes preloaded for us. And then after class, after I've gotten that video recording, that will go up right next to it. Down at the bottom is where you'll find any homework that we're going to have for that day. I do have a short assignment that I want you guys to complete for me today. It's an introduction video, just because I've never had any of you guys in class before. Obviously, we're supposed to be a larger class than just the people that are here today. But I am going to have everybody complete this introduction video so that I can start to get to know you. I can learn how to pronounce your name. I know if you have a preferred different name or pronouns or what have you. So I want to go over this with you real quick. You can access any homework from the bottom of our daily page. You can access it from the assignments tab. You can go into modules, or it is on our class Canvas page on the main page right here. It'll have your assignments listed. Right, so your introduction video that I want you to do for me, this is due tonight or tomorrow, my apologies, this is due tomorrow. I want you to say your first and last name. Please make sure that you speak slowly and clearly so that I can understand how to pronounce it. And then again, if you have a different preferred name like Mike instead of Michael that you prefer to go by, just let me know. Tell me how you felt about math last semester. So did you do prime last semester? Did you have a different math class last semester? Did you have no math class last semester? I'm going to let you know where you are. Did you do well? If you had a math class, did you or do you tend to struggle in math? Were you proud of your work? Do you need extra help? Do you think you tried your best? Just let me know a little bit about who you are as a math learner. And then pick out from this list down below some other things that you're comfortable telling me about yourself so that we can start to get to know each other. So that's what I want you guys to do for homework tonight, and then you will upload that into the Canvas assignment. Now, I do want to dig in just a little bit into some content today. We're not going to be able to do it in groups like I had originally been hoping for, but I just want to kind of get our brains working and back into that mathematical mindset. So, to get us thinking, on February 13th, 2012, so almost 10 years ago, Apple announced the 25 billion app countdown promotion. They awarded a $10,000 iTunes Store gift card to the person who downloaded the 25th billionth app from their app store. Apple had a counter on their website so that customers could see the current number of downloaded apps. And a mathematician named Dan Meyer recorded 16 minutes of this counter going on the Apple website on Friday, February 24th, 2012, beginning at 6:46 p.m. Pacific Standard Time. So when I change the screen here in just a moment, we're going to watch this counter going in the background, but what I want you guys focused on is how can you use the information on that counter to try to figure out when the 25th billionth iTunes app was downloaded. So we want to try to make a prediction given the information that we've got from this counter. So kind of have that in the back of your mind. Grab some paper, grab a writing utensil. I'm going to start this counter, and I want you guys to try to get information from this counter that you think would be useful in figuring out when the 25th billionth app was downloaded. All right, so I'm going to go ahead and start this. If you look up here in the upper right corner of the video screen, you can see Friday, February 24th, 6:26 p.m., and you can see the counter going. The time on his computer clock changes. So here in a minute, it'll say 6:27 p.m. How can you use the information on the screen, the date, the time, and the counter to try to make a prediction about when the 25th billionth app is going to be downloaded? I'm going to give you guys a little bit of time to watch this, to think about the question, to record any information that you think might be useful in answering the question. Good afternoon, Kyla. Kyla, since you joined us just a little bit late, what we're doing, this is a counter that Apple had up on their website almost 10 years ago, this was screen captured by a mathematician named Dan Meyer. You can see his name up here in the corner. He did a screen capture on his computer. This is Friday, February 24th of 2012, so almost 10 years ago. The time is now 6:28 p.m. Oh, it just changed to 6:29 p.m. The App Store is about to hit 25 billion downloads, and the person that downloads the 25th billionth app got a $10,000 App Store gift card to use however they chose. And so we are trying to predict when that would be occurring. So we have the current date and time, and then we've got this counter here. And I'm giving everybody a chance to kind of look at it, watch the counter, watch the time. And for those of you that have been doing this for just a little bit, what I'm looking for, and I want you to send me this as a direct message in the chat. So direct message meaning only I can see it. I want you to send me a direct message with your best guess for the month and the day that the 25th billionth app was downloaded. This is in 2012. 2012 was a leap year. So this particular February had 29 days, not 28 days. So I want you to take your best guess. Do you think that the 25th billionth app was downloaded still in February? Do you think they made it into March before it was downloaded? Do you think it went beyond that? Do you think it was April or May? And I want you to give me your best guess as far as the actual day. So month and day. And if you want to get really, really out there, see if you can also guess the time. So month and day is what I'm looking for in the chat in a direct message so that only I can see it. And then if you really want to go out on a limb, be quite adventurous, see if you can guess the time. We've got 6 people in here today, so I'm looking for 6 guesses. I'd like to have everybody's guesses in the next 5 minutes or so. Awesome, I've got 1 guess in already. Five more to go. Give me your best guess based on the information that's being presented here for when you think the 25th billionth app was downloaded. Like I mentioned, this was a leap year, so this particular February had 29 days, not 28. Nobody's being graded on their guesses. Just give me your best guess. I've got 2 guesses in. People are feeling adventurous. They're coming in with times also. Nice work. See if we can get 4 more. Awesome. Half the people have their guesses in. We've got one that's really close too. Got 4 guesses in. Two of them are really close to the correct date. That's really interesting. See if we can get our last 2 guesses in. Last 2 people. Give me your best guess. Like I said, nobody's being graded on their guesses. I just want to get you thinking again. Awesome. Okay. So now I'm curious to hear from you guys. How did you arrive at your estimation? Was it just a guess? Or did you use a mathematical process? If you did use a mathematical process, tell me what you did. Go ahead and type it into the chat, or you're welcome to unmute your mic and let me know. Awesome. Thank you, Ralph. I've got yours. Thank you, Yasmin. Thank you, Rihanna. Did you use a mathematical process, or was it just a guess? It's like we had a lot of people that were taking guesses, which is totally fine. Like I said, nobody was being graded on it. And taking your best guess was absolutely appropriate if that's what you did. So I've collected a little bit of data from that timer. This is 90 seconds worth of data. So from the time the video starts until it hits a minute and a half, 90 seconds. This is what the counter says at each of those spots. What does this data tell us? What do you notice is staying the same? What do you notice is changing? Is there anything that stands out to you when we look at the same data that we were just presented with a moment ago on the counter, but we look at it in a table form like this? What can this data tell us? What do you notice that's changing? What do you notice that's staying the same? Ooh, nice observation. It's right around 5,000, an increase of 5,000 every 10 seconds. I'm going to go ahead and record that observation. About 5,000 more downloads every 10 seconds. Interesting. Is it exactly 5,000 more downloads every 10 seconds? Not exactly, but it's ballparking around there. And when you're working with numbers this big, if it's about 5,000 every 10 seconds, does that come across as being a reasonably constant rate of change, even though it's not a precisely constant rate of change? Yeah. So if we notice something that's kind of constant on our rate of change, what would that tell us? What can we do with it if it has a constant rate of change? How could we use that to help us? Do we even want it to have a constant rate of change? Would it be better or worse if it has a constant rate of change? What do you guys think? Would it be more or less helpful for us to make our prediction if it has a rate of change that's close to constant? Would that make a prediction easier or harder to achieve? Ooh, nice thoughts. Couple great direct messages here. I absolutely agree that it's going to make it easier for us to make a prediction. Having that somewhat constant or close to constant rate of change means that we can write some kind of equation to help us make this prediction. What type of equation could we possibly write, or could we potentially write, to help us figure this out? What kind of equation would have a constant rate of change? I'm going to write that idea down. With a constant rate of change, we can write an equation to help us predict. There we go. Love it. Sorry, I was looking down while I was writing for a little bit. Love it, love it, love it. Okay, so I got two different things going on here in the chat, and I love both of them. So to find the rate, we can do y2 minus y1 over x2 minus x1. Anybody remember what we call that? That is our rate. That has a special name. I'm going to write down the other thing that was given to me in the chat because I think that might help us out here. We got y equals mx plus b. Does anybody remember what we call the rate in this kind of a situation? Or in this case, it would be represented by the m here. Does anybody remember what we call that? You guys have some great ideas. I'm super excited. Yes, that's absolutely correct. That would be our slope. A constant rate is the slope. Okay, so I want to take this information that's in this 90-second sample data table, and I want to show you what it looks like if we plot it. What do you notice about that plot? What do you notice about that plot? Does that fit with what we thought, with our predictions that we made on the previous screen? It looks very linear, yes. Now I'm curious, when you look at the y-axis, how many digits are they looking at on the y-axis here where it says counter? How many places do they have there? Six places. So when I'm looking over here, they're only looking at these numbers right here to do their plots. Why do you think they're only looking at these? Why do you think they would only be looking at these 6 places to do the plot? Why not look at all of them? Absolutely correct. That's the only thing that's changing. The first 5 digits, at least in the 90 seconds of sample data that we have, the first 5 digits don't change at all. And in fact, that number that's like right in the middle, it's 4, 4, and then 5, 5, 5, 5, 5, 5, 5 for all the rest of them. So like right at the beginning of that blue box that I put around each of them, that one doesn't really change after the first 10 seconds. So even though that counter looked like it was going pretty quickly, it's taking quite a while for it to get all the way over to the millions place. Okay, so one of my last questions for you today is how, if I made a graph like this, and I extended it out further beyond 90 seconds, because obviously it didn't hit 25 million apps in 90 seconds. How could I use this type of a scatter plot, or even changing it into the equation of a line, to predict when that app was downloaded? What would I be looking for? How could I use that? How could we use a scatter plot or a graph or a linear function to predict when the 25th billionth app was downloaded? Think about it. We have our graph here. We have the counter on one axis. What's on the other axis? The time. Time is on our other axis. Is the time On the x-axis or the y-axis? Across the bottom there, is that the x-axis or is that the y-axis? That is our x-axis. So this is being used as our independent variable. So that means whatever is showing up on the counter is what type of variable? That is our dependent variable, yes. The counter is our y, which is our dependent. What was our big question again? What did we want to know in this situation? Was I looking for a when answer, or was I looking for a total count answer? I was looking for a when. Yes. So I was looking for time. Did we have a count? If I had a linear function, if we actually developed a linear equation like you guys suggested, y equals mx plus b, finding our slope, our constant rate, how could I use that then to answer a when question? How could I use that to answer a when question? There you go. Yes. We could set that equal to the 25th billionth app and solve for x to find the time. Sub 25 billion. And for y, solve for x, the time. Awesome. Fantastic work today, guys. I'm really, really excited at how I saw you guys reactivate those parts of your brain. All right, so to just kind of wrap us up here, I had talked at the beginning, but I'm not sure everybody was in here at that point. What I want you to do for homework tonight is the introduction video. If you had me first semester, you might have done this already. That's okay. I still want you to do it again. There's always more I can find out about you. The introduction video assignment, you can get to it from assignments over here. You can get to it from our daily page. You get to our daily page from the Math Prime homepage by coming down here and clicking on today's lesson right underneath the Zoom link, right above the bell schedule. You can also go to modules, but then here is our assignment. Make sure you clearly and slowly say your first and last name so that I can learn how to pronounce it correctly. Tell me how you felt about math last semester, or if you didn't have a math class, tell me that. Kind of tell me where you are as a learner so that I know how to meet you where you are and make sure I'm providing the best learning environment for you. And then tell me a little bit about yourself. Pick at least 4 of the things off this list to tell me about yourself. I'm going to be the only one seeing these videos. Other than that, that is all I've got for you today. I hope you guys have a fantastic rest of your day. If you have any questions, I'm happy to stick around. If you're more comfortable typing out your questions, you can send me a message in Canvas. Just let me know. But if you don't have any questions, or if you don't have any questions right now, you are welcome to sign off for today. And hopefully I'll get to see you guys in person tomorrow.